Alright, so this video is going to wrap up 10.1 and we're going to be talking about the derivative. So the important part here is to look at the second slide, go down to the first paragraph, second sentence, where it says that the derivative is the instantaneous rate of change. Alright, so if you're asked to find instantaneous velocity, what you're essentially going to be doing is finding the derivative. And what we're going to do is use this definition here. There's two of them, but we're going to use this definition. And notice how it uses a's in this definition. This can easily be replaced with x's. Alright, so f prime of a, that's how we would pronounce that, equals the limit as h approaches 0 of f of a plus h minus f of a all over h. Alright, and so I wrote underneath it, if the problem uses x's instead, how you would substitute in. Now, real quick, I wrote down 3 examples, and you want to add this to your guided notes because this is important. These are 3 examples of functions defined at x equals 0 but not differentiable at x equals 0. So if you were asked to find the derivative of x prime 0 for these example problems, you wouldn't be able to do so, because if you look at x equals 0 in the first example, do you see how there's a sharp angle there? If there is not a curve, it's not differentiable. Alright, so there's a sharp angle. We can't differentiate that at x equals 0. The same thing for number 2. If we look at x equals 0 there, you see how the line or the graph goes straight up the y-axis at x equals 0. That would be non-differentiable at x equals 0. And then for the third one, we have jump discontinuity at x equals 0. So, another case where it would be non-differentiable. So keep that in mind when you're asked to differentiate at a point. Okay, so example 4. All right, we're going to find the derivative at a point. And notice we were given x's instead of a's, so I made that substitution in our formula. So we want to find f prime of 4 if f of x equals 2x squared minus 3. All right, another way you could think of this is what is the instantaneous velocity at 4 seconds. So they go hand in hand, the instantaneous rate of change and derivative. Alright, so how are we going to handle this? Well, we write down our formula, and then the first thing you want to do is replace x with 4. So you're going to write f prime of 4. And then we're going to say f of 4 plus h minus f of 4 all over h. Alright, so that's the first step. Now the next step is to go ahead and take 4 plus h and plug that in everywhere you see x. So I'm going to have 2 times, alright, I see the x, so now I replace it with 4 plus h squared minus 3, and then minus f of 4. So I take 4 and plug it in here. So that's going to be 2 times 4 squared minus 3 all over h. Alright, and I'm going to pause this because I need some more room. Alright, so we have the 2 times 4 plus h squared. That's how we're going to rewrite it. And then we're going to subtract 3. And then if we look, this minus 2 times 4 squared minus 3. Alright, so we're going to do 4 squared, which is 16. Well, let's put this in parentheses. Okay, so we're going to go back. So minus, and then let's evaluate. Alright, so 4 squared is 16, times 2 is 32. And then minus 3 is going to be 29. Alright, all over h. Alright, so now we're going to have 2 times, so let's FOIL the 4 plus h. So 4 times 4 is 16, plus 4h. The inners give us a 4h, plus h squared. And then we have a minus 3 minus 29, so it's going to give us a minus 32 all over h. Alright, let's clean up inside parentheses. So you're going to have 16 plus 8h plus h squared minus 32 all over 2. Alright, so let's distribute the 2. So the limit as h approaches 0. So we have 2 times 16, so that's going to give us 32. 2 times 8h, 16h. Let's make that look better. And then 2 times h squared is 2h squared. And then minus 32 all over h. The 32 and then minus 32, that'll give you 0. So we're left with 16h plus 2h squared over h. Alright, and I probably should have pointed this out in the very beginning. If we would have plugged in 0 for h right away, we obviously can't do that. It would be dividing by 0. Alright, so what we did was we worked through. We got to a point where now we can factor out an h here. So that'll leave us with 2h plus 16 over h. And now we can cancel that h out. Alright, so we're left with the limit as h approaches 0 of 2h plus 16. Alright, now we can go ahead and plug 0 in for h. So when we do that, we get 2 times 0 plus 16. That gives us 16. So f prime of 4, finding the derivative at the point f prime of 4 is going to be 16. If this, if this was part of a word problem, and this was the equation or the function for distance traveled, all right, and this was your time. So if you plugged in t equals 4 and you had to find the instantaneous velocity at that point, the instantaneous velocity would be 16. So they're related. So I want to point that out because you're going to be doing some word problems in your homework.